Hello everyone, let's do question 2.1. The letters A to H in the table below represent 8 organic compounds. So we have these compounds A, B, C, D, E, F, G, H. Okay, we'll discuss these compounds as we answer the questions. Right. The first question says, define the term organic compound. What is an organic compound? Right. According to the examination guidelines, you should be able to define an organic compound is a compound that contains carbon atoms, or it could be molecules that contain carbon atoms. But please take note, there are some molecules that contain carbon atoms which are not what? Which are not organic, which are not considered to be organic. Like let's take for example, we have carbon dioxide, we have carbon monoxide, we have carbonates. All these are not organic, but they contain carbon. We have carbides, we have cyanides. We also have pure carbons, like the diamond. This is a pure carbon, it's not considered to be organic. We also have graphite. Right, please take note of that. So organic compounds are compounds that contain carbon atoms, or are molecules that contain carbon atoms. Right, question 2. Let's answer these questions using the given molecules or the given compounds. Write down the IUPAC name of compound E. Let's look at compound E. Right, this is compound E. So what do we do? So we have to determine the number of carbon atoms in the longest chain. Remember, for the naming, for the IUPAC name, we need to have the prefix, and then we need to have the stem, and then we need to have the suffix. The stem is coming from the number of carbon atoms. Remember that if there's one carbon is meth, two carbons eth, and then three carbons prop, four carbons but, like that, right? And then prefix will come from the position of the substituents. All right, we'll talk about that. And then the suffix is coming from the functional group. Right. So let's look at compound E. Right, we have to count the carbon atoms, and then we have to include the ones that have what? That have the functional group. So I can count from here. This is 1, 2, 3, 4. Even 1, 2, 3, 4. So I can start here with this one. Even if I want, I can start with this. They'll give us the same thing. Right, let's number the carbon atoms. 1, 2, 3, 4. And then we number them backwards again. Right, and then we have 1, 2, 3, 4. Right, so we have 4 carbon atoms. Right, so we have but, okay, and then the suffix. What is the functional group? It's a double bond, so this is an alkene. And then which position is this double bond? We have 2 carbons here. We have carbon 1 if we're going backwards, we have carbon 3 if we're moving forward. So we take the one with the lower number, so it's carbon 1, so it's but 1. And then the suffix is coming from the functional group or the homologous series. So this is an alkene, so it's going to be N. Right. What about the prefix? Right, if you check, we have our carbon chain, which is this, and then we have some substituents which are attached to this carbon chain. We have a methyl group, right? Where is it? In carbon 3, right? And then we have another methyl group which is in carbon 2. So we have carbon 2, we have methyl group in carbon 2, we have methyl group in carbon 3. So this is a dimethyl, but in carbon what? 2 and 3. So we write the positions 2, then separate with a comma, and then between the positions and the substituent group you put a dash like this, and then it's 2 comma 3 dimethyl, because there are 2 of them, di for 2, so it's dimethyl. So this is the complete name now. We have 2 comma 3 dimethyl but 1 N. Then you can also write it like this, is 2 comma 3 dimethyl 1 butene. Like this. You can write it like this. Okay. Write compound H. What type of a compound is this? Let's number the carbons. We have 1, 2, 3, 4. We're numbering the ones with what? With the functional group. Then number it backwards. 1, 2, 3, 4. Our stem again is going to be but. But now, what is the functional group here? This is a ketone. This is a ketone. And then it's in carbon what? In carbon 2. Then we remove the E here. And then 2 on. Because it's butanon. Butanon. So it's butane 2 on. Right? The on is from the ketone group. Right? And then do we have any substituent group? We don't have any substituent attached to the main branch here. So this is butane 2 on. You can also write it like 2 butanon, like this. You can also write it like just like butanon. It's fine. Why butanon? Because it is a ketone. So this functional group can be on this carbon or on this carbon. If still it is on this carbon, it will be having the same name. So it's not changing anything. So you can write it as butanon, but the appropriate one will be this one. All right, let's do 2.3. We're answering these questions using the given compounds. Right, 231. Write down the structural formula of compound B. Right, compound B. What is the structural formula? The structural formula is showing us which atom is attached to which, right? And then the atoms are represented by their chemical symbols, and the bonds are represented by the lines or the straight lines that we're going to use. So we have CH3 and then CH2. So we have this C. It is attached to what? To 3 hydrogens. So they'll be like, this is the hydrogen, another hydrogen, another hydrogen. There must be 4 bonds around carbon. Then it means this carbon also be joined or bonded to another carbon. And then if you check here, there are how many CH2s? There are 3 of them. So we have 1, 2, 3. And then each carbon here is bonded to 2 hydrogens. So there's a hydrogen there, there's hydrogen there, hydrogen there, hydrogen there, right? And then also, this is the third one, still hydrogen, and then hydrogen. Now we have 1, 2, 3. The fifth one is going to be this one, bonded to oxygens, 2 of them. So this should be this bonded to an oxygen and then another oxygen there. Okay, right. And then oxygen, around oxygen there must be 2 bonds. And then there's another one bonded to a carbon and then with 3 hydrogens. Just that. Just know that the structural formula, you're using the chemical symbols, showing you which atom is attached to which. And then your bonds, you use what? The lines, like that. What type of a compound is this? This should be an ester from the reaction between a carboxylic acid and an alcohol. Then 232, structural formula of compound C. This is 4-ethyl, so it means we have an ethyl group bonded to the main branch. Then 3,3 difluoro, it means we have 2 fluorides and they are both attached to carbon 3. And then hexane, this is giving us what? The main branch, right? Hexane means how many carbons? 6 of them. So you can start with those carbons. 1, 2, 3, 4, 5, 6. So we have those carbons, 6 of them. And then at 4, this number is 1, 2, 3, 4, 5, 6. Right, at 4, we have an ethyl group. So we can have an ethyl group here. So we have CH2 here, and then bonded to another carbon, and then CH3. That is the ethyl group. This whole thing here is the ethyl group attached to carbon 4. Difluoro, carbon 3. So we have fluoride there, and fluoride there. Fluoride, fluoride. Done. And then the rest, we just put the hydrogens. So it's going to be like this. Make sure there are 4 bonds around the carbon. It's going to be like that. In 2, 3, 3. Right, the general formula of the homologous series to which compound E belongs. Compound E, we say that is an alkene. So alkenes, what is the general formula of the alkenes? It will be Cn and then H2N. Just remember this. You have to remember this. From alkanes to alkenes. Alkanes will be CnH2n plus 2. Then for the alkenes, remove these two. You remain with CnH2n. Then for the alkynes, further remove the 2, but you no longer have a 2 to remove. So we're going to say minus 2. So it's CnH2n minus 2 like that. So you have to remember. Okay. For the alkanes, alkenes, alkynes like that. Right. And then 2, 3, 4. What is the structural formula of the functional group of compound F? Functional group of compound F. So what do we have here? We have this. So what is that? That's a ketone. That's a ketone. We can write that as the functional group. And then that is the ketone there. Then you can put R there. And then another R there. Or even if you write it like this, then we have like this is still okay. Right. That is the functional group of compound F. Right. The IUPAC name of the alcohol needed to produce compound B. Like I said, we said that compound B is what? This is compound B. We talked about it. Okay. This is an ester which comes from the reaction of carboxylic acid and an alcohol. So you can divide actually, you can actually divide this molecule into two parts, right? So what you do, you cut here where there's the single bond. The carbon is bonded to two oxygens here. It's bonded to an oxygen with a double bond and also an oxygen with a single bond. So you divide where there's a single bond like this. The one with the double bond is coming from the carboxylic acid. The one with the single bond is coming from the alcohol. And then this is the O coming from the OH. So meaning that the alcohol here will be CH3 and then OH. Okay, this O is the O from the OH. And then what is the name of this alcohol? This is methanol. All right, let's answer these questions using the given compounds. What is a functional isomer? All right, these are compounds that have the same molecular formula but different functional groups, meaning that these are molecules that have the same molecular formula but belonging to different homologous series. Right, let's check compound G. Compound G is a carboxylic acid. That's a carboxylic acid. Okay, and then compound B is an ester. Compound B is an ester. So they belong to different homologous series. But are their molecular formula the same? Yes, they are. Because how many carbons do we have? For compound B, we have how many carbons? One. And then here we have three of them because it's times three here. So it's going to be 1, 4, and then 5, 6. And then this side, for compound G, we have 1, 2, 3, 4, 5, 6 again. 6 carbons. Let's check hydrogens. We have 3 here and then 6 here. From 2 times 3, there's 6. So it's 3 plus 6, which is 9. And then 12. I'm counting the hydrogens. So it's 12. And then this side, we have 3, 6, 8, 11, then 12. So we have 12 hydrogens also. And then 2 oxygens there. And then 2 oxygens there. So they have the same molecular formula, but they have different functional groups, or they belong to different homologous series. So the functional isomer of G is B. And then which ones are the chain isomers of each other? What are chain isomers? These are molecules that have the same molecular formula but different types of chains, meaning that they have different structural formula, isn't it? But they belong to the same homologous series. they belong to the same homologous series. So let's check for those. All right, we said G is in the carboxylic acid. Even D is a carboxylic acid, right? This is a ketone. This is a ketone. 1, 2, 3, 4. 1, 2, 3, 4, 5. No, they're different, right? And then should be D and G, which are carboxylic acids, right? This is an alkane, heptanoic acid. Okay, 7 carbons here. 1, 2, 3, 4, 5, 6. So it should be D and G. They have the same molecular formula. It's only that they have different what? They have different types of chains. They have different structural formulae. Should be D and G.